Presentation was mostly like for juniors, so they didn't actually know about a lot how to use those tools. So yeah, so the goal is to talk about AI a little bit in terms of how we can change the way to develop software today, especially for juniors, associate software engineers. Learning how to use AI effectively is one of the biggest, I think, at least for me, career advantage that you can have. So the goal of this presentation is not to replace us as programmers, software developers, things like that. Instead, it's just like, how can we use AI to help us to become faster learners, or how to write better code, solve problems in a way that can be more efficient, right? So let's spend more time thinking about software design, things like that, instead of doing those repetitive work. So this quick presentation will introduce those AI tools. I use many of those sometimes during the day. Explain when you can use each one, and also share some practical workflows that can start, so we can discuss how we can use those tools in our daily development workflows. So if you think about it, like, things are too fast today, right? So a couple of years ago, we actually didn't talk a lot about LLM models and how can we use that for our workflows, programming, things like that. So software engineer has actually changed dramatically over the last few years. If you still think, well, I see those changes since 2014, but the biggest change in LLM models and also coding was mostly in 2022. So instead of spending hours searching documentation or Stack Overflow as that behavior, like Google, and also check Stack Overflow, how we can solve some issues, check documentations, and also have the knowledge itself. That was the stack that we used a couple of years ago. And now it's different, right? So AI can answer your question, can generate examples, can explain some of the code that you are not familiar with, and even suggest some improvements. So AI allows us to actually automate those repetitive tasks. Generate, for instance, unit tests, write some documentation, review your code. So everything that you usually spend months, weeks, or days can quickly be done right now using those LLM models. And the goal is, at least I think you should start using those tools, at least to quickly understand your code base when you are not familiar with new project that you are starting off. However, what I'm seeing the last years is like, AI is not replacing software engineers. It's more like augmenting us, right? So how can we as software engineers know how to work with AI in a way that can be more productive? So that's the goal. So think as AI as like an experienced teammate or principal software engineer, senior software engineer that is always available to help you. I just want to highlight here, I think sometimes I see like those AI tools accelerating like 8 times the way that I work today. Some people say 30 times, it depends. We're going to discuss how I measure those accelerations and metrics later on. Okay, so there isn't actually one AI tool that does everything perfectly today. But things are so fast today and actually accurate in the last year from this year that sometimes we get scared, right? So people start using GitHub Copilot, for instance, at the beginning. And GitHub Copilot is excellent when you are writing some code. It works directly in your IDE, VS Code, and provides some code completion suggestions. Yeah, that's great. But things start changing when we see like Gemini Claude raising in the last year. So Gemini is very strong for technical research, architecture discussions, documentations. If you want to understand how to aggregate your code base with Google technology, that's great as well. And for us as seniors, I see Cloud as like the best options today, because Cloud is outstanding when you are working with a large portion of your repos and code, and it can analyze like thousands of lines of code, explain context systems, and help you understand the architecture. And finally, we have ChatGPT, right? Most versatility assistant was the first one that rise in the last years. So I use it for debugging, brainstorming ideas, like learning new technologies, writing documentations, or solving general software engineers problems. And one thing that you have to keep in mind that things are really fast right now. In 1 week, 1 month, you cannot compare those models as you compared 1 month ago, because sometimes they release an updated version that can do exactly what you do with Copilot or with Gemini or with Claude. And the goal is always test and try all of them as much as you can. People started using some GitHub Copilot. So that's great. That's actually a good pair programming tool that I actually use. So think as GitHub Copilot as your pair programming that sit next to you, follow step by step, code by code, line by line. So while you are typing, it can make some predictions what you are trying to type and build and propose some suggestions or implementation. So that's great. And it can actually generate repetitive codes, right? You can create until unit tests, for instance. It can help you select a portion of your code and then refactor the methods, and also speed up some of your development process. But don't accept everything. They are just suggestions. You should always be the human in the middle to validate everything. And that's why it's important to you to understand the programming language and also the technology itself, and not just say, accept everything and do everything, because that can be a huge mistake. I can give you some examples later on. So always review the generated code, understand what it does, and verify that it actually follows the project standards, the company standards, and so on. Right? I talked with a couple of junior software engineers, and they said, okay, I'm using those LLM models to code to me. I actually don't understand what is going on, and I just accept and just push a production. Yeah, and I said, really? So you should not do that. It's a bad approach. And I understand that, especially the type of technology that you are using can be very challenging to understand. For instance, like Rust, it's a kind of a complex programming language, but yeah, always keep in mind that it's just a pair programming. You have to understand things. And then we have Claude, right? So Claude is, at least for me particularly, it's very useful when you are working with a large and unfamiliar project. Imagine it's like you are joining a new team with hundreds of thousands of lines of code. Instead of manually exploring the repo, you can ask Claude to explain the architecture, identify some important modules, trace the execution workflow, and summarize how the future, the system itself works. And Claude actually helps a lot, transform the days of exploration, months of explorations in a couple of hours of days. It depends on how complex is the project. So for me, Claude doesn't replace reading the code, but it actually helps you know where you can look first and start from there. So a good AI workflow, for me at least, has 4 simple steps. So first, you have to understand the problem. Before asking AI anything, make sure that you clearly know what you are trying to solve. Then the second step will be write a good prompt, provide enough context and try to explain the requirements and describe what you expect in the end. And today, this is getting better and better, because when we started in 2022, was mostly like a prompt issue. People would not prompt better text to the LLM models, but this is getting better and better. Today, when you type just a couple of words, like 2 lines, what actually is going on in the LLM models. It extends that as a better prompt before entering the system to get your output. So they are basically using, okay, LLM model, get this input from the user, improve it, make a better prompt. Now input in the LLM model again and start coding. That's how it works today. And people are seeing that as like a default approach. And third, the third step, it's basically generate the solution, right? So let the AI produce the code, that try to understand what is going on and get your ideas implemented from there. And finally, always verify everything. Run tests, review your code, validate the logic, and ensure that the solution actually met the requirements. And there is one extra step that I do that I see that helped me a lot during the process of coding and using AI. Today, it's becoming cheap to code and also to generate tests. So try to cover with tests as much as you can as you implement new features and create new bug fixes, things like that. That is going to help you a lot. And finally, personally, I think from experience that if you start documenting things with AI or without AI, it also helps you, because you have to think that LLM models are based on text generation. As much as you can document your code, you can just create like a doc folder and place there the documentation for your modules, like the software development documentation, user guides. It refers back on the way and put that context on the window. The window is like the memory available for the LLM model to take the actions. And if you have that on your code base, in your folder, it helps a lot. And never skip verification steps. All right. The quality of the AI output depends dramatically on the quality of your prompt. So if you ask vague questions, you will receive some vague answers. This is changing from a couple of months from now. But let's say, instead of saying, fix my REST API, try to explain actually more context, like explain the framework, the error, the expected behavior, and some constraints, or all the constraints that you can imagine. And include relevant code, like error messages, requirements, and also sometimes project context beforehand. And that will for sure give you a better answer as fast as you can. Because there is one issue today, especially people that are not from computer science area. They just type a vague questions on the terminal and they generate a bunch of lines of code, the whole project itself, and it just run, okay, it's working. But okay, that was like 10 minutes, 15 minutes, maybe less. But then you're going to spend months just trying to fix the issues that you face on the way. If you provide better prompts and also verify on the way, that's going to calibrate the process of generation of your project code and also help you get better results in the end. I'm going to give an example. Let's say that as a senior software engineer, I prompt something and then I took some time to elaborate the prompt and I generate the code with 15 minutes. But on the way, I decided to actually document, create unit tests, and ask some questions to validate if everything is correct. Take some time to look on the code. Okay, that took me 8 hours. And in the end, you just spend 1 day, 2 days to get the final results. But if you just decide with a couple of lines, say, generate everything, and you create the whole workflow, whole system without actually creating unit tests, verifying the code, documenting things, you're going to end up spending 2 weeks, 1 month or more, especially if you don't know the code, if you don't know how to code, and if you don't know the problem. So the more specific your prompt is, the better and more useful the response will be. Good prompting is actually becoming an important engineering skills. And yeah, so if you actually can communicate good, if you can write good, if you can code, that it's just going to aggregate and produce better results in the end. And this is just an example, right? So this is too vague for me, write a Python code for a REST API. Then try to build a Flask API with this technology, this style, create unit tests, and so on. Too short, but it's better for sure. So one of the best uses of AI, at least for me, is learning. So you don't need me to explain how to use Claude, how to use Copilot. You can just go to ChatGPT, Claude, whatever, and ask them, okay, how can I use that? And teach me how to use ChatGPT, teach you how to use the Cloud CLI, right? So you can learn a lot with it. When you don't understand the concept, just ask the AI to explain, right? It helps a lot at different levels of your complexity. And if you are debugging or trying to see how to solve some exceptions, ask the AI how to explain the stack trace line by line, for instance. And yeah, I know that this is like, we know that, but I like just to formally mention that. Ask the model to explain when you don't know things. For instance, when you are studying some system design, you can ask the AI to compare different architectures. You can discuss some trade-offs. You can explain why one approach is better than another one, instead of simply copying answers. Use your AI as your personal mentor, right? As your professor, your teacher, and try to get things done by them. You are always learning, and we have years and years of experience, like almost 20 years. I'm still learning. Every time we have a new framework, every time you get to a project that you have to learn things new, and that's it. And now we have something very expert. Of course, we have our hallucinations sometimes, but it's there. It's there for you, and cheap to ask and get answers fast. Then debugging with AI, it's much more effective when you provide enough information. So don't simply say my code doesn't work, right? And that's too vague. So include some error message, the stack trace, relevant code, some context, some documentation. So what I expect as a result. You can even provide an example, like this is the question, this is something that I expect as an answer. And that helps a lot. So ask the AI to identify possible root cases instead of only asking how to fix. If you start asking, okay, we have this problem, this is the context that I have so far, I don't exactly know what is going on and how to fix it, but try to identify possible root cases instead of just say, fix this. This creates a much more productive debugging conversation and also often leads to a faster solution. And this is what I actually want to mention to you. How fast you produce results depends on how fast you know things and how much you verify your code and try to understand things. Because I can simply create the full solution, and in the end spend days trying to fix and debug things. But if I do step by step, broke the full problem in small pieces of problems and try to solve those small pieces of problems and verify things, that's get better. And in the end, you deliver faster. So remember to debug. Remember, basically, debugging is about understanding your problem, right? Not just removing the error from your plate and move on. So finally, let's just talk about how to be responsible. This is important to mention because people forget about it. Just a couple of examples: never paste confidential company information, customer data, passwords, keys, what else? Property code into your public AI systems. If your code is public available, like OpenQ, right? Okay, this is available on GitHub for everyone. It gets easier, but if you get some code that is proprietary, okay, you can still try to use those open access, but you have to or create a sandbox that doesn't provide those keys and be more secure. Then just copy and say, okay, read my code and do everything. So always verify AI-generated code as well before committing things. Sometimes you might do some mistakes and provide some commits with some security branches, right? So write tests. Perform code review, a lot of code review, and ensure that the solution meets the security and quality standards. because AI is a powerful assistant, right? But it's not just accountable for your code. At the end of the day, you are the software engineers responsible for everything that's gonna reach productions at some time. We are using AI, but we are responsible for the code. So use AI to become faster, smarter, and more productive, but never stop thinking critically.